Hello everyone, we are here. We are going to do science in seconds. Today we're talking about the weirdo effect called the Casimir Effect. It's a weird one, it's a bizarre one. Here we go. Now this is not the Casimir Effect of Seinfeld. If you guys have ever watched the old show Seinfeld, it's not Casimir like that. And it's not Led Zeppelin either, although that's kind of cool. Now this is a Casimir Effect. This effect actually occurs in quantum mechanics, the bizarre world of quantum mechanics. And what it is, I have listed here, it's a tiny, attractive, I'm going to jot this down for you guys. It's a tiny, attractive force between two uncharged, keyword, uncharged conducting plates that are parallel to each other. These plates have to be exactly parallel. Remember, parallel means they're not touching, they're in perfect lines back to each other. So we got two plates in a vacuum. This vacuum I'm talking about is more like empty space. Imagine out there in space it's all empty. Not your household cleaner vacuum, but this is more empty space vacuum. So think about it like that. Although your house cleaner vacuum does have a completely empty tube, which allows it to clean up everything and allows it to suck up all the dirt in your house. But not that kind of vacuum cleaner. Anyway, so we're talking about empty space here. So the Casimir Effect is as a tiny attractive force between two plates. Let me see if I can grab one of my other fancy markers over here so you guys can. So if you have two plates like this, they actually kind of like will come together in empty space. They'll crash together a little bit. And it's kind of weird when you think about it. It technically shouldn't be happening in empty space. Well, it turns out that a vacuum or empty space is not actually empty. That's weird. It's not empty. What quantum physicists have discovered is that empty space that Isaac Newton thought, Mr. Isaac Fig Newton in all his brilliance, he thought space was completely empty, but we actually now know that empty space is actually composed of all these little particles popping in and out of existence. All these little bubbling particles just keep popping in and out of existence, and they exist for like a split second in time, not even nanoseconds. And that's really what empty space is composed of. And our boy here in 1948, a dude predicted this effect. This guy's name, not a household name, but maybe he will be one day. Mr. Hendrik, you can probably guess his last name. Let me make sure I spell it correctly here. Mr. Hendrik Casimir. I don't know if it's Casimir. I like Cashmere. Like the cashmere sweaters of Seinfeld. Okay, so in 1948, this dude predicted this kind of effect because he realized what was happening if you have two uncharged plates in empty space. What occurs is an attractive force. Why is that? Technically, if it's empty, the plates should just be like this. The plates are like this, but instead they go like this. They line up and they go boom, and they come together. The reason they do that is that there's many more particles. They have to be very close together too, so they have to be like very, very super tiny distance between them. And the reason for that is there's so many other particles in empty space popping out of existence outside and around them that density difference, that there's much less happening in here, that outside density, it wants to move it together. So all these particles are actually pushing them together. Because remember in nature, if you think about same thing with high pressure versus low pressure, things want to move towards low pressure. And so it's the same kind of density difference here that a great analogy for you guys is if you think about, I don't know if I have room on my board here, but just imagine it. Imagine two ships in the water. This is a great analogy, great thought experiment. Two ships are in the water, and if they're very close together, that the big waves, those big slooshing waves, those are particles popping in and out of existence, they're all sloshing together. And what happens is those two ships, like our two uncharged conducting plates, they'll actually be really close together, and as sloshing, there's actually no waves happening between the space here. And so because of all this activity happening out here, these two ships will go and actually come together. So that's a great analogy to imagine what's actually happening in the quantum world. There's lots of waves going on. We just can't see it. We can only perceive it mathematically, and with quantum computers and weirdo nanotechnology, we can kind of know that there's quantum effects going on in particle accelerators and different particle physics. Scientists know that quantum material is always popping in and out, and there's a bunch of waves. And so what happens is these two plates, just like the two ships, they collect or clink together, if you will. So that is the wonderful, amazing Casimir Effect. And what's more is this Casimir Effect could have huge ramifications, however you say it, have huge impact in the future with nanotechnology, perhaps, because remember, this is the quantum world. This is like a subatomic particle world, so really tiny particles, super, super teeny tiny. And because of that, it could have implications in nanotechnology. Maybe there could be, because these plates move together with nanotech, you could actually have potentially nanotech that is frictionless, and so maybe the currents and other different moving parts will be completely frictionless, and the speeds of computers, nanotechnology will be even faster. So maybe our nanobot invasion will happen even quicker than we thought, or not. Maybe you can stop the nanobot invasion. And that's all today for our Science in Seconds on the Casimir Effect. Thank you for watching. Please like and sub. Peace out.